Our next lesson is on basic trig. Now on the ACT test, they don't necessarily expect you to be through a whole trig class, but there are 4 trig questions on the test, which I know doesn't seem like a lot, but typically my students really enjoy the trig, so we're going to go over it and we're going to make sure we get those 4 right. Now the first 2 questions on the trig portion of the test will be about basic trig, which you might know as SOHCAHTOA and the derivatives of SOHCAHTOA. So the first thing I have written on your notes are the formulas for sine, cosine, and tangent. And then we also have the formulas for cosecant, secant, and cotangent, which are the reciprocal functions of those. So moving along, we have our first problem where you're provided a right triangle, and I expect you to be able to write those trig ratios for all of the 6 trig functions. So the first one is sine of theta. Theta is just like another variable, just like x. So I always have my students kind of draw a smiley face where theta is. That's your reference point. So sine is the opposite side divided by the hypotenuse. So the side who is opposite of you from that angle is 3. And the hypotenuse on that triangle is 5. Cosine is adjacent over hypotenuse. So adjacent means next to you, which is a 4, over hypotenuse, which is a 5. And then tangent is opposite over adjacent. So opposite of you is a 3, and adjacent to you is the 4. Now cosecant is just the sine, but flipped upside down, or the reciprocal. So instead of being opposite over hypotenuse, he's hypotenuse over opposite. Secant is the reciprocal of cosine, so 5 over 4. And cotangent is the reciprocal of tangent, so 4 over 3. So once you have the first 3 trig functions, it's very easy to find the last 3. The problem on the ACT is they typically don't ask you for all 6 of them. They ask you just for one particular one, so you got to know all the formulas. This is an old ACT problem. It says for the triangle shown below, what is the value for the sine of z? So here is your reference point, angle z. Sine, remember the formula, is opposite over hypotenuse. So opposite of you is 12, and the hypotenuse is 13. So your answer, always leave it in exact form, is 12 over 13. For the next question, it says, what is true about angle A? So here's our reference point, angle A. And they want to know if cosine is 12 over 13. Well, 12 is opposite, and cosine is always adjacent over hypotenuse. So no, that's not true. Is sine 12 over 13? Well, let's see. Sine's opposite over hypotenuse. Opposite over hypotenuse, so yes, that is true. Now that was a fairly easy question, so I'm just going to stop, but if you wanted to continue on and check all the rest of them to make sure you didn't do anything silly, that's fine. Okay, the next question says, if the tangent of theta is 2 over the square root of 77, what is the sine of theta? So let's think about what they gave us. They told us the tangent is 2 over square root of 77. Well, the formula for tangent is opposite over adjacent, which means that the opposite side of theta I could label as a 2, and then the adjacent side I can label as the square root of 77. Now they want to know something totally different. They want to know the sine. Well, sine, remember, is opposite over hypotenuse. Well, I have the opposite, 2. I don't think I know the hypotenuse. Not yet, at least. But I bet I can figure it out. Let's try some Pythagorean theorem. So Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. So that would be a 4 plus 77. So that would be x squared equals 81. So your hypotenuse is a 9. So 2 over 9 would be the value of my sine function, and that's the answer. Now, as I kind of looked through the answers, I knew 2 had to be in the numerator, so there was only one option that worked. I probably did a little too much work, but that's okay. Okay, this next question says that the sine of A is 3 over 7. Now, if I look at my triangle, I notice they have one of the legs already labeled, and here's my reference point. He would be the opposite leg. But they labeled him as a 14 instead of a 3, like I would have anticipated. Well, trig ratios are just like any other ratio, they can be reduced. So the 3 over 7 used to be something totally different, some other ratio. So what we're going to have to do here is set up a proportion. We're going to have to say, all right, 3 over 7 is supposed to be opposite over hypotenuse. But if I look at my triangle, the opposite is really a 14. And the hypotenuse, I don't really know. So I'm going to do a little cross multiplication, and I'm going to get 98 divided by 3 for the x. What did they want? They wanted the length of AB, which happens to be where my x is located, so I think I'm done. The answer is J. Okay, example 5, the cosecant of alpha is 4 over 3. And alpha is an acute angle. What's the cosine of alpha? So I'm going to draw myself a little triangle. They just had to tell you that business about it being an acute angle, because if you knew a lot about trig, which most of us don't, you would realize that there could be more than one answer there. So the cosecant of alpha is 4 over 3. And remember, cosecant's formula is hypotenuse over adjacent. So the hypotenuse I'm going to have to label as a 4, and the adjacent side I'm going to label as a 3. Well, they want to know cosine, and remember cosine is adjacent over, oops, I messed up, excuse me, back up. Cosecant is hypotenuse over opposite. I need to fix this. So the 3 should really be on the opposite side. Okay. Cosine is supposed to be adjacent over hypotenuse. Well, if I look at my formula, I have the hypotenuse, I do not have the adjacent side. So again, I got to do a little Pythagorean theorem, where I say 3 squared plus my mystery side squared equals hypotenuse squared. So let's see, that would be 16 minus the 9, so that'd be 7. So x is the square root of 7. And now I think I'm good to go. I want adjacent over hypotenuse. So adjacent would be square root of 7, and the hypotenuse would be 4. And my answer is D. Sorry about that. Okay, the next problem is actually a story problem, but it's still very, very easy. And what makes it even more simple is they gave you a labeled diagram, which is very nice. The 70 degrees goes right here in the corner if you can't figure out what my diagram is trying to say. And the whole question is, what is the length of AB? So I need to figure out how to calculate the hypotenuse. And if you notice, all of your answer choices are not actually answers, they're what you would have typed on your calculator. So they don't even want you to find the answer, they just want you to figure out how you would have found the answer. So let's look at what we have. If this is our reference point down here at 70 degrees, we've got the opposite, and we've got the hypotenuse, which tells me I would use sine. I would have set up the sine of 70 equals 260 over x. And if I tried to solve this proportion, when I cross multiplied, I'd actually end up doing a division problem. I would take the 260 and I'd end up dividing it by the sine of 70. And there we go. Now, as you go deeper into your trig unit in Algebra 2, you're going to be able to solve those proportions very quickly without thinking about cross multiplying, because you're going to do so many of them. But something to realize about the ACT is they don't actually expect you to find the answer, because they want to make sure that if you don't have a calculator, you can still do it. Okay, this next question says we have alpha, beta, and gamma for our angles, and A, B, and C for our sides. What is true about the product of the tangent of beta times the tangent of gamma? Now, the tangent of beta would be, here's my reference point. Remember, tangent is opposite over adjacent. So opposite is B, and adjacent is C. So tangent of beta is B over C times, and then if I switch it up and I go to gamma, which is right here, his tangent would be opposite over adjacent, or C over B. And when I think about multiplying these two fractions together, the C's and the B's all cancel, and it gives you a 1. So it's a very weird worded question, but a very easy question to do. Okay, the next question says, What is the cotangent of angle A? Well, again, you need to know the formula, and once you know the formula, it's really easy. Cotangent is adjacent over opposite. So here's A, there's our reference point. Adjacent to you would be the square root of 4 minus x squared. And then opposite of you would be x. So I think the answer is E. Okay, this is a more complicated concept in trigonometry, and as you get into Algebra 2, closer to your ACT, you actually will see this. But the first question, or the first concept, is converting between radians and degrees. Now, just like we can convert meters into feet, we can convert from radians to degrees. And if you notice on your calculator, back in geometry, we used to always tell you to keep everything in degree mode. Well, in Algebra 2, sometimes we want to be in radian mode. And the ACT often will ask you to convert things between the two modes. So the first question says, what is the measure of the angle in degrees if it's 2 pi over 3 radians? And if I look at my directions, it says to go from radians to degrees to multiply by 180 over pi. So 2 pi over 3 times the 180 over pi. You should notice that the pi's cancel out. And the rest of this I can just do on my calculator. If you do 2 times 180 and then divide it by 3, let's see, you end up with 120 degrees. Now the next question goes the other way around. It says I have a 60-degree angle and I want you to measure that in radians. So we're going to start with 60 degrees. And the directions at the top say to go the other direction, multiply by pi over 180. Now what's unusual about radians is they're always left in what's called radian mode, which means exact, and we're going to leave the pi as part of the answer. So what I want you to notice is that 60 is in the numerator and 180 is in the denominator. So if you take 60 and divide it by 180, which is just a little fraction, and then hit math enter enter on your calculator, you're going to get 1/3. So an acceptable answer is 1/3 pi. Always leave the pi in terms of pi. But in trig, we like to throw the pi up in the numerator, so pi over 3 is how you'll typically see that written. Okay, the next question says, the measure of each interior angle of a regular polygon is measured with that formula. Okay, we know that. What is the measure of each interior angle of a regular polygon in radians? So we're going to write down our formula again. N minus 2 times 180 divided by n. And then to convert everything to radians, remember we multiply by pi over 180. So at the very least, I should notice that the 180s are going to cancel. And nothing else really cancels. So my answer is going to be n minus 2. There's still a pi up there. And all that's going to be divided by n. So I kind of look at my answers. It looks like C is the correct answer. Okay, the unit circle is a very complicated idea in trig, and you will be introduced to this in Algebra 2. A couple things I just want you to realize about the unit circle. And if you already know this, forgive me. It starts over here in your terminal side at 0 degrees, and it measures in a counterclockwise direction, which is a little strange. So from here to here, that's a 90-degree angle, and that's how the unit circle is measured. 90 degrees, and then to the next axis is 180 degrees, and then 270, and then 360. What's unique about the unit circle is it loops forever and ever and ever, so you can keep doing rotations and keep adding on degrees. Now you'll notice on this particular unit circle form I gave you, it says 90 degrees or pi over 2. I've given you both the degree measurement and the radian measurement. Just like how we can convert from degrees to radians, I already did it for you. There are angles in between all those axes, many, many, many angles. And when you go into trig, trig will ask you to memorize some of the most commonly used measurements and angles. So you're not going to memorize every single one, but the most commonly used ones you will be memorizing. All students take calculus as a little mnemonic device that we use to memorize which trig functions are positive in which quadrant. So right here in the first quadrant it says A, and A actually does still represent all functions, meaning sine, cosine, and tangent are all, and all of their reciprocal functions are positive in that quadrant. The student's part, the S, actually represents sine. So that means only the sine function is positive in that quadrant. T represents the tangent function, and C represents the cosine. Now when I say sine, tangent, and cosine, their reciprocal functions are also positive. So for instance, sine, his reciprocal function was cosecant, so both of them are positive. But typically the ACT will only ask you about the three common functions, sine, cosine, and tangent. So when I look at the next problem, it says, for any x between 0 and 2 pi, if the sine is greater than 0 and the cosine is less than 0, what are the possible values of x? Well, let's think about what that means. If the sine is greater than 0, any number greater than 0 means it's positive. So basically, sine has to be positive wherever I'm looking. If the cosine is less than 0, that means cosine has to be negative. So I'm looking for a part of the unit circle where sine is positive but cosine is negative. So I'm going to back one slide to look at my unit circle. And the first clue was sine had to be positive. Well, there's two places where sine is positive. Sine is positive right here in this quadrant, and sine is positive right here in this quadrant. But the other clue said cosine had to be negative. Well, which of these quadrants is cosine negative? Well, he's not negative in the first quadrant because everybody's positive there. So it looks like this is the quadrant that I'm looking in, between these two axis points. So I'm looking between pi over 2 and pi, or 90 and 180. So go back to the question. Of course they wanted in radians, and we said between pi over 2 and pi. That was a more complicated trig question. There's only 2 of that style on the ACT. So if you miss them, it's not the end of the world. Okay, the next section is about using formulas. And often they'll take a really complicated trig problem, but they'll give you the formula so it's completely doable. So the sine of pi over 12 is what we need to calculate. And then they give you this little formula here, which is the difference of two angles. And it says if you can break an angle up into a subtraction problem, it becomes this. Ugh. So, they told you how to break up pi over 12. They said to break them up like pi over 3 minus pi over 4. So that means the pi over 3 is going to be the alpha, and the pi over 4 is going to be the beta. So what you would have to do next, if you did this the way they were expecting you to do it, would take the sine of alpha, so in our case it'd be the sine of pi over 3. So if I read my chart, sine of pi over 3 is square root of 3 over 2. And then the cosine of beta, which in our case, I should write this down. Cosine of beta would be cosine of pi over 4. So cosine of pi over 4 is square root of 2 over 2. And then there's a minus in the formula. Cosine of alpha, remember alpha was pi over 3. So cosine of pi over 3 is 1/2. Times the sine of beta. Sine of pi over 4 is square root of 2 over 2. Okay. Now we're going to have to combine like terms here. Let's see, square root of 6 over 2. Oops, excuse me, not 2. Square root of 6 over 4. Minus square root of 2 over 4, which is equivalent to answer K. Now, I'll share a little secret with you. You could have also just used your calculator. You could have put your calculator in radian mode, and you could have just typed in the sine of pi over 12, and it would have given you some ugly decimal. And then as you type in all of these answer choices, one of them, turns out K, would have matched that ugly decimal, and that would have been maybe a quicker way to do that question. So don't necessarily get trapped by how they want you to do the problem. Just do the problem whatever is easier for you. Okay, this last example here is asking us to use what's called law of cosines. Now you may or may not have ever seen law of cosines, and it really doesn't matter because they kind of gave you law of cosines, and there he is. And it tells you the lengths of the triangle are A, B, and C, and then they give you some information in the problem. However, they already gave you a labeled diagram, so don't think too hard about this. If they want you to figure out how far apart the two boats are, that means you're going to use this formula. Now, looking at the formula and looking at our answer choices, I think I can eliminate some just because they don't look anything like our formula. For instance, A, he's missing, half the formula. The next one I think I can eliminate is C and E, because you notice there's a subtraction sign right here before the 2AB, and these both had addition signs, so I got rid of those. So now I look at choices B and D, and the only differences I notice are that B says the cosine of 5 degrees at the end of the problem, and D has the cosine of 85 degrees. Well, as I look at my diagram, that's a 5-degree angle. They don't even show 85 degrees anywhere on this triangle. So I think the answer is B. I know the answer is B. So that's a little glimpse of what you're going to see on the 4 trig questions on your ACT test. Again, it's not the end of the world if you miss some of them, but I think you could easily get 2 of the 4 correct without really breaking a sweat.